Hello. Question number 7 on the midterm has two parts. The first one is just a straight-up definition. What is the definition for B is a basis for vector space V? Since just definition, it's pretty quick just to write that down. We have B is a basis for the vector space V if it's a subset of V and it is linearly independent and it spans V. So those are the two little things. Next question is a bunch of true and false. Let's go ahead and go through these one by one. The first one says that if I take some vector, let's start off. V is a vector space and B, or beta maybe, is a basis for V. Our first question says that if I take some vector and I put it inside of this set, then the result is a dependent, linearly dependent set. And we're going to say this is true. Let's say this is true. There's really only two types of vectors you might want to put in there. Stuff not in B and stuff in B. So if I put something not in B, then we know that we can write out that vector as a linear combination of vectors inside B. So that means if I just move that B over, or that other vector over in that relation, or expressing that vector as a linear combination of guys in V, then I have a dependence relation which says that this is linearly dependent. Now if I put something else that's inside of B, and I put that in there, well, we're going to think about this as a collection, and so what that means is that we'll have this repeated vector in there. We'll have B comma B, or BI comma BI, and then we'll have the relation BI minus BI equals 0, and that gives us another dependence relation. So we get that it's linearly dependent in both situations. Next question says, if we have a subset B prime of B, then B prime is linearly independent. Now, this is also true because if we had some dependence relation inside of B prime, then we could get a dependence relation using those vectors inside of B, and that would work out. Yeah, here we're also thinking about this as more of a collection, and we're not going to worry about repeats. So this guy's also true. So the next one is that if I have some vector and it's not equal to 0, and I write it out as a linear combination of the elements of my basis, then there's an I such that Ci equals 0. This isn't necessarily true. This doesn't make any sense. For example, I could take the linear combination, the sum from I equals 1 to n of just 1 times bi. Okay? And in this guy, all my coefficients are 1. Right? So it's not necessarily true that one of these coefficients has to be 0. So this guy is false. Okay. Next one, if I have some vector and it's not equal to 0, and I write it as a linear combination of some vectors, then there's an I such that it's not equal to 0. Well, this is true, because if all of my coefficients were 0, then we're talking about the sum of 0 times bi, which is just the sum of zeros, which is just 0. Okay? And we explicitly said that our vector is not 0. So I equals 1 to n. So this guy's true. Yeah. There is some guy that's non-zero. The next one, if I have some subset of V, and we have that our basis is inside of that set, then the span of our set, sigma, is all of V. And that's true also, because we already know that we can express any vector in V as a linear combination of vectors inside B. So if I throw some other vectors there, then yeah, I can still express any vector inside of V as a linear combination of stuff inside of sigma, because I've already got B in there. This guy's true as well. Well, that's it for question number 7. If you have any questions, you can ask in the comments below or in class. Thank you very much.